So we're starting Chapter 2. Chapter 2 is formulas. We're going to find out soon that formulas are going to be an equation, something with an equals, where you have just like a single variable equals something. So x equals something, y equals something. That's kind of, we're going to do a lot of that stuff in this chapter. Want to start out just with like an example or two. And so for this, you could kind of do a little bit of chicken scratchings if you wanted to, but I'm going to say Daytona, they have a 24-hour car race at Daytona. And let's say that a car averages 103 miles per hour, so 103 average, so including stops and all that driver changes and so on, for 24 hours. And the question is, how far do they go? The equation is going to be distance equals speed times time. And if you don't know the equation, you still can figure out how to combine something if you look at the units. My speed is 103 miles per hour. So I'm going to put that in for S. Technically they call that substituting. We're replacing S with 103. Then my time is going to be 24 hours. I caught on to this way too late in my math science career. If you don't know how to do a problem, you forget the equation. Do you agree? If I just look at the units there, hours is the same as hours over 1, right?
Yeah.
Like 5 is the same as 5 over 1, 7 is the same as 7 over 1. If I take this fraction here, miles per hour, times hours over 1, do you agree that hours can cancel? If you're multiplying, just look at the units. If you're multiplying two fractions, you can cancel something in the numerator or something in the denominator, if it's multiplication. And now, what's the only unit that's left in that whole problem?
The 1 and the miles.
Yep, the miles and the 1. You know, so it's going to be like miles over 1, or I'm just going to leave it as miles. So in other words, if you want to figure out how far is this car going to go, you just need to multiply the numbers together, just like we did the units. So I have 103 times 24, so the car would go 2,472 miles. All right, so it's 2,472 miles. A quick comment on things from my class. When you get questions like this, I'm going to be looking for you to show your work like this. First, I want to see the equation. Then I want to see you substitute or put numbers in for each of the variables, kind of like I did in this line, and then work through to get the answer. A lot of students don't like that I'm asking them to show their work, but trust me, this is the easy way to do it, and you'll find that you get them right a lot more often if you do it this way. Here's the definition of a formula. So formula I'm going to say is a single variable equals something. So single variable equals, and I'm going to squeeze a little something in over there, equals something. And if you were to do some examples, you could just have like a plain old like x equals 4. You know, x is a single variable, it equals something. Anyone remember the equation for the area of a circle? A equals pi r squared. So a equals pi r squared, that's another example of a formula. It's a, it's a single variable equals something. It'd probably be good to kind of define a variable. That's something that's going to come up in class. It's going to be a letter or symbol that's used to stand for something where the values may change. So it's usually we use things like x's and y's, but you could use s for speed, a for area. It's going to be a letter or symbol. You do enough math and science, they start using Greek letters in there too. Letter or symbol that stands for something.
Like this.
I would. So it stands for something like the area of a circle or the distance a car travels. And I should add after that, that may change. So that A for the area of a circle, circles have different areas. Some are big, some are small, so A can change. A could be different numbers. The R in here, is the R also a variable? R would be the what part of a circle? The radius of a circle? So, okay, so you learned this 6th grade? So A and R are both going to be variables because different circles could have different lengths for the radius. Different circles could have different areas. The pi, is pi going to be a variable?
No.
Can pi change? Nope, it's always that 3.14159 something, 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 something. So pi is not a variable, just the a and the r. We clear on variables?
Yep.
Another term, and I'm not going to ask you to define this, but I want you to know what it is. When we took earlier, let me get rid of that black line, and we took and put numbers in, so we put this 103 in for the speed, and we put the 24 in for time. They call that substituting. If you think of, like, I was watching a volleyball game last week, got partway through, you had the people that were leaving kind of go by the line, the people that were coming in go by the line facing the other way, and then they wrote down like numbers of people that were leaving, people that were coming in, that they were substituting. Some people came in and replaced other people who were leaving. So substitution, that's just replacing a variable with a number. So replacing a variable with a number. So when you see questions in the book that say substitute 4 in for X and 7 in for Y or something like that, they're telling you take and replace that letter with that number that they give you. So if we were to say A equals L times W. So that's going to be the area of a rectangle is going to be the length times the width. So then the question might say something like find the area of a rectangle with, and they'll often write it out, I'm going to abbreviate it to save some time, with L equals 5, and so when the length is 5 and the width is 2. So if we want to do that, we take those two numbers, we take the 5, that's going to go in and replace the L, then we take the 2, and we substitute that in for W, we replace the W with the 2, so we end up with the area is 5 times 2, for a total of 10 for the area. I've been corrected. I probably should put in like the units as well. If you had 5 inches and 2 inches, or centimeters and centimeters, and then when you multiply the numbers together, it would end up being 5 inches, get in there small, times 2 inches. And if you do inches times inches, it gives you 10 square inches, so inches squared. That's the better way to do it. Last section, rounding. This officially isn't part of this section of notes, but it comes up in the review questions. A good skill to have, so rounding. The key to rounding is you round up when the digit that you're cutting off is what or bigger?
5.
Yep, very good. So round up when the number you're cutting off is 5 or larger. So in other words, if I had something like, let's say 4.37, if I wanted to round it to right there and just say this is going to be 4 point something, is it a 4.3 or 4.4? 4.4, because if I'm cutting off this number here, that's bigger than a 5, so it's a 5 or bigger, so we have to take the 3 and round it up, so it'd be a 4.4. If instead I had a problem like, well, maybe let's say we wanted to round it to this spot, we wanted to round it there, does it become a 4 or a 5?
It stays 4.
Yep, it stays a 4 because you look at the 3 isn't 5 or larger, so then we don't round the 4 up. So if you rounded that just to like the 1 spot, it would be a 4. So that's a cool little remember. So it's 4 and below, keep it low, 5 and above, give it a shove. So you can kind of remember it that way. Want to throw out some like place numbers at you a second. So I'm going to go up to like the million spot. So I'm going to leave myself a little bit of room to write above it. And I'm going to say, why don't we go with 7. Ooh, need to grab a pen. So if I have 7, 6, 5, 4, 3, 2, 1. I just need a number. Then I'll do a decimal point, and we'll do a 1, 2, 3 on the other side. So you'll see questions that say round to a certain place value. So the 1 is going to be the ones place. Does that make sense? The 2 is the tens. It'd be nice if it was 2s because it fit with my number. 3 would be hundreds. You need to make sure you're ending with a DS, the hundreds, not a TH. That's going to come in a bit. 4 is going to be thousands. 5 is so 10,000s. I'm running out of space. 6 is 100,000s. I'm going to do 100,000. And then 7 would be millions. Hopefully yours looks neater than mine, but millions for that. If you're going down to the 0.1, instead of being the tens place, it's the tenth. Nice, so tenth. The reason for that, and I think this might help us remember it, is if you have a problem like 0.1, and you could skip writing this if you want, but 0.1 is the same as 1/10, 1 over 10. That's why they call it the tenth place. Or if you had like a 0.3, that's going to be the same as 3 over 10. So that's why they refer to that decimal point as the tenth, because it's 1 over 10. If you had 0.12, that's going to be the same as 12 over, any guesses? Nice. Over 100. So since that's 12 over 100, what are we going to call the 2 in our like big long number thing up above? Nice. That's going to be the hundredth spot. So above the 2 we have hundredths. So you'll notice that these here are ending with the THS instead of just the S on the end. And then the very last one, the 3, would be thousandths. Do 2 examples, then we're done. And we'll do some practice like this kind of in the next few weeks. If we were to say round 42,368 to the hundredth spot, so the DS, hundreds, not hundredths spot. What's going to be the, I guess, so we're rounding it to what number? The 4, 2, 3, 6, so round it to the 3. Maybe I should scroll on, because the 3 is going to be that hundred spot, the third one over. So we need to look at that 3 then and say, okay, if we're rounding to the 3, do we keep it a 3, make it a 4? Make it a 4. Yep, 5 or above, give it a shove. So 42,400. Then we would write the zeros after, because if you don't have the zeros, then it's not 42,400 anymore, it's just 424. Okay for those? Yep. If we do one example on the other side, we'll say round 3.8297 to the tenths spot. So now we're looking at the 8, but that first decimal point was the tenths. So now we look at the 8 and say, do we leave it at 8, make it a 9? Leave it in 8, because you look at the 2, and the 2 is lower than 5, so lower than, what was the phrase? 4 and below, keep it below, keep it low. So we have 3.8. Now you don't add the zeros afterwards, so don't put zeros on the end like I just did. If you're rounding it to that 10th spot, you don't know what happens after that technically. You just know that it's 0.8. Any questions on the rounding? Okay. One final rule for rounding in my classes, and it's kind of ambiguous, it's not real clear. Usually how I look for rounding is this. Round correctly, and don't round too much. So when you have a number that gives you like a big decimal answer, I'm okay with you rounding it to a decimal point or 2 decimal places or something like that. Just when you hack off your number from what your calculator gives you, make sure you round that last digit correctly. Is that fair? And by don't round too much, I wouldn't say something like, if you have like 82.74, you know, you could round that to 80, well, 7436182 9. So say you have that. If you want to round that to this spot here, would you leave it a 2, make it a 3?
3.
3. If you want to round it here, leave it at 8, make it a 9. 8, 2, and so on. So by rounding it, don't round too much. You could round down here for sure. You could round to here, say 82.74. You even could round here and say 82.7. The 83 is pushing it a little bit, because if this was 82.9 something, yeah, sure, it's 83. But I'd be a little careful not to round to 83. Definitely don't round to this spot and say it's 80. That's just way off. Does that make sense? So when in doubt, put another decimal point in there. So I do 82.74, 82.7, something like that. We'll figure it out.